So my name's Shannon McCormick. I'm a senior incident responder at Salesforce, and today we're going to talk about from alert to action, covering a macOS security alert. So pretty much you can think of this as an introduction to incident response. So a lot of great security talks I've seen have had cat photos, but I'm really into dogs. So this morning I offer you dog photos in exchange for your attention. And the big photo at the bottom is a little sketch of my two dogs at home. So I'm very into dogs, and they take up most of my life. But so again, my name is Shannon. My career so far has been in detection engineering and incident response. I'm currently over at Salesforce in our security incident response team. We do have subdomains and subspecialties. So for example, I'm in a team called endpoint response, which focuses more on asset compromise and endpoint incidents. So that's what we're going to talk through today, with the context being Objective-C is obviously focused on macOS. Before we get rolling, I did want to call out some of my teammates and thank them for their time and help in supporting this presentation. So thank you to Aaron, Luke, and Adam. So let's get rolling. We're going to start off with just an introduction. What is security incident response? Just to baseline the room to understand what this is. So the classical definition is just an event or an occurrence that results in some sort of jeopardy of the CIA triad, which stands for confidentiality, integrity, availability of either a system or information that passes through that system. But if you're like me, like, what does that mean? That's too vague. I need specifics. That feels like it could be anything. And if you think about it, that's kind of on purpose. If you think about a security incident response program at a corporation, they cover a lot of different domains and can have a lot of different areas of expertise. So I think it's best to learn with an example and some breakings and to break down the various domains of incident response. So if we work at a corporation and we sell a product that's to a customer, you might have customer incidents. So you might have a shared responsibility model where you need to help a customer remediate a problem on their end while they use your product. You might have a privacy incident. You might have unauthorized access to data, sensitive data, addresses, social security numbers, payment information. You could have vulnerabilities, security flaws, bugs in a product. You can also have cloud security, think AWS, Azure, GCP, think EC2 instances exposed to the internet and then taken over for coin mining resources. You can have traditional security alerts like phishing, impossible travel, restricted travel. So some companies don't do business with other countries. Also, insider threats. So think about employees possibly taking intellectual property for their own gain, either to other companies or to other countries that are trying to compete. A classical example now is AI and the competition between the US and China, and then endpoints. So we will focus this talk on endpoints. It's more focused on compromise of internal assets in the environment. So think laptops assigned to an employee, servers supporting the infrastructure or the products. So we're going to focus on the endpoint incident response piece. But I like to really just say that incident response is chaos. It's living in chaos and being okay with it. Because really anything can come in and you're expected to drive it to remediation. There is kind of some insanity to that, but there's also some fun in the sense that you see new problems daily and you get to take on new interesting challenges, and you're very much just always continuously learning and continuously seeing new things. So the gist of this slide is incident response is living in chaos and being fine with it and doing good work regardless of the chaos. So let's add a little bit of context to incident response too. It's important, again, talking in a corporate environment, to take into consideration scale. So if you think of incident response for small companies, like let's say 100, 200, that's a very different scenario and situation than for a large corporation of say 80,000 employees. Because in that context, every single employee has at least one asset. And we can take into consideration that all of these employees are spread across the globe. So you can think they're not just in the US or Europe, they're in Asia Pacific. There's different regulations, laws, there's different applications that certain cultures use. There's a lot of variability that scale introduces to incident response. So with that in mind, if we think about what is the perfect scenario, like what is the best case So my job as an incident responder is not just chaos. The answer is preventative security controls. So blocking things from running before they even get onto the host. So blocking where a user can navigate to, blocking a certain application from running, whether it's signed or not, or whether it's on an allow list in an enterprise. That's the ideal end goal that would solve a lot of problems in incident response. But if we take into consideration scale and the various job responsibilities, the various regions, it's a hard problem to solve. And it inevitably leads to some headbutting between security that wants to block everything, and then folks like developers or engineers that want to move quickly and try new things out, new tools, new resources, and be quick to develop code and products and push the company forward. If we look at this from a business perspective, in the end, security doesn't always win because we're not necessarily generating revenue. So in the end, middle grounds tend to be formed. So we accept some risk in the environment, and then we have teams like incident responders in place to be ready and capable when things do happen. And for the context of this presentation, let's assume all of the endpoints we have in this environment are macOS. So everything we're triaging is macOS related. We're in the environment. All the alerts are for a macOS host. So you get it. You all understand incident response now. That was enough context. Let's dive in. So we're all incident responders now. You're given an alert. A host in the enterprise, a Node.js script executed and reached out, had an outbound connection attempt to an external domain, specifically 94.1.131. So what do we do? Where do we start? How do we go? This is all you're given. What do you do? Again, living in the chaos and being fine with it. So let's look at some open source intelligence toolings like VirusTotal. This is a hard screenshot to see, and that's kind of on purpose because I just kind of want to give you some brief context, and then we're going to get rolling through the end-to-end incident process. So pretty much the TLDR of the VirusTotal context is this is bad. We can look at the community notes, we can look at other detections, and we see that this IP is known to be a command and control IP. It's part of a known threat actor's infrastructure. So with that additional context in mind, this goes from that's not great to this looks pretty bad. This is like a known threat actor that has some pretty, like is trying to steal information off hosts. So from an enterprise perspective, we want to remediate and contain this quickly. So where do you start? What do you want to do? How do you go about this? So again, I said incident response is living in the chaos, but it's important to find meaning and direction in that chaos. So a good way to start is to use an incident response framework like MITRE ATT&CK here. So typically on incident response teams, there's playbooks or a run book that will tell people, here are the steps you should follow for these scenarios. But if you think about it, it takes away a little bit of the critical thinking that's important when you experience something new. The ability to see a problem and solve it analytically and not necessarily lean completely on these steps. Because if you do kind of 1, 2, 3, and you don't always think about the outcome, and if you're doing the right process, you lose that critical thinking and dynamic element of incident response. So this is just to say, playbooks and runbooks are great for documentation, standards, repeatability, but you should never rely too heavily on them. And you should think more of like the attack lifecycle, which MITRE does a great job of documenting. And you should think in terms of stages of an attack when informing what you want to do next, what data you want to look at, and how you want to go about your process. So let's do it. Let's take into context the alert we just got. So using the same visual from the last slide, which is pretty much a visual of the MITRE ATT&CK framework if you've never seen it before, where it shows at the top kind of the initial stages and the end, the kind of end goal of exfiltration, impact, command and control for further instructions. So initial access, credential access, discovery, persistence, lateral movement, etc. So if we take into consideration the alert we have in this example of a Node.js script executed on a host, outbound connection attempt, 94.131, we are here. You are at the C2 stage. So with that in mind, we're going to use the framework to inform us what we want to investigate next. What questions do we have? What do we want to look at to inform how we drive this to resolution? So let's do it. So when looking at the framework, it's important to think about what happened next. Because if you think as an incident responder, you care about remediation and containment. You care about containing that blast radius so it doesn't propagate to other hosts in your environment. So we're going to start with looking at the future stages of an attack. And our questions are, was the external connection successful? Was any further stages dropped to the host? Or any of our security controls that we have in place successful with blocking this activity? So again, answers to those questions will inform us what we do next. And again, the remediation and containment and the scoping that we do as incident responders. But it's important, even if we get all these answers and we're like, great, it was blocked. We don't just move on. We don't just move on with our lives. We want to build the whole story. We want to see end to end what happened here. So we want to look back at the earlier stages of the framework. And we want to say, how did we get to this point? How did this user navigate here? How did this host run? Like, how did this outbound connection happen on the host? So we want to answer these questions. So what was the initial access point? So like social engineering, was it phishing? Was it some sort of other manipulation? Was it bundled with a legitimate application? Were they just naive? Were there any persistence? Were there any credentials collected that we need to rotate? Can we attribute the behaviors that we're collecting to a known actor? So these are all questions that we've created by, again, reviewing MITRE and saying, what are the earlier stages? How is this possible? So now we have kind of like a framework of how we're going to go about working this incident end to end. So let's do it. Let's dive into the data. So again, we're going to start with what happened next, because we care about that end implication, especially because we're so far down in the attack lifecycle. So let's look at it. All right. So if we look at the external domain, hopefully you can see this. The 94.131 IP, specifically the outbound connection, is on port 1224. And if we look at what it resolves to, it's a domain that's hosting a file called main5_504. Again, this is hard to see, apologies. But if we look at virus total for that domain, we can see that hosted at the content hosted there is a base 64 encoded text file. And then if we deobfuscate it, we can actually see that it's a Python file used for malware persistence. Now you might be wondering, how did I get from A to B? And I'm not going to explain that. One, because this is an incident response talk, and I want to show you the high-level view end to end. Two, it's a good example of malware analysis and when you would engage someone like Patrick or Chris to help go deeper, understand things better. But also, the literal expert of Mac malware analysis is here and has given you a book. So it's a good reason to crack open your book and to read more about it. So let's think about it from an incident response perspective. So we see that this file is hosted at this domain. We see that if the connection was successful, it would have been dropped onto the host. So our first question is, was that successful? Did a further stage end up on the host? And in this case, we see that our security controls actually worked. Got blocked. We don't have any further stages to care about when doing host analysis. But it's important to still take into consideration, like Chris said, the high-level behaviors of what the malware is doing. Because from an incident response perspective, if this was successful, I would want to know what to look for next. Again, I want to keep forming questions, answering them, forming questions, answering them. So if I know what the further stages do, so if I know it's persistence, I know it's data exfiltration, I know what to do, what data to look at next, and I know what remediation I want to ask the user or the host, etc. So let's continue. We've answered the first part of what happened next. So thankfully, the external connection was not successful. Thankfully, further stages were not dropped, though they are part of this campaign. And thankfully, our security controls actually worked, which is great. But we're not done. Let's go back. Let's run it back. Let's understand how we got to this point. How did this host reach out to this outbound connection? How did this application, if it is an application, end up on the host? And can we attribute it to any known behaviors in the industry? So let's run it back. Let's go back to the alert. Again, here's the quick overview of the Node.js script. But it's important, I think, one of the most important pieces of data when looking at security alerts is process trees, the hierarchy of this is the command, this was the parent that spawned that child. So taking into consideration the process tree, we can further inform kind of the question of what caused this outbound connection. So let's take a closer look. So here we have the overview, the command from the alert, the parent process. So what stands out to me, and I hope it stood out to you, is that what spawned this process is coming from the user's downloads folder. That's pretty weird. That's not normal. Like if you're a developer, you're normally in a standardized file path of like where developers work. Things aren't being run right out of the downloads folder. So that to me is weird. And that's kind of the next thread I'm going to chase of why is this file here? How did this get here? And why is it running? So that's reviewing the alert gives me a lot of additional context to chase down further. So let's keep going. Let's look at the downloads on the host. So we're able to connect to the host and triage the file system. An important piece of data that's also on Mac hosts is what's called an extended attribute. You can think of it as a little piece of metadata that's attached to any of the files on your system. So if we look, so in this screenshot here, I'm looking at the downloads again, because that's where we saw the parent process. If you look at all of the files and you look at the permissions, group owner, etc. If there's a little @ symbol at the end of that file permission, that means there's an extended attribute, a part of that data. So from an incident response perspective, this extended attribute will help me understand where the file originated from. Again, I want to piece together the story of how did this end up here. So again, you'll see 2 files related to the alert, just to review. So we're looking for React Node test master. We see a zip file. We see a React Node test master zip. So that's the original download. And then once you unzip it, obviously it becomes like a directory. So that's why there are 2 entries on this host. So extended attributes, they're important, they're helpful. Let's look at them. So in this screenshot, and I hope you can see it, there are 2 extended attributes that are very helpful with incident response. The first screenshot is the KD item where from. So it tells us the URL and the refer where the file originated from. So if you can see in the screenshot there, you'll see it's coming from GitHub, a repo called ahacom, and then React Node test. The other useful extended attribute, it's what's called com apple quarantine. So it tells us the application where the download originated from. If you think about it, if you think about browsers, they could have whatever they want. Firefox, Opera, Chrome, Safari. So in terms of investigating browser history, it's important to know what application it came from. I can obviously pull down all of the history of all of the browsers on the host, but I like to limit the data I pull so I have more focused. I don't want to be buried in data, pretty much. I mean, it's fine, but I'll move a lot faster if I have a limited data set and a clear time window. So from this information, we know that the download originated from Chrome. We also know the URL, where the download specifically came from. So again, we have more context. But I still want to know, how did they end up there? Why did this person go to this GitHub repo? You might be asking, well, maybe like your developers use GitHub. And you're right, maybe we do. But normally in corporate environments, there's an internal domain. So it'll be called something like GitHub/company, whatever. So ahacom stands out as unusual. And then I can verify internally that it's not a known used repo for any just random projects. With that being in mind, this repo stands out as odd. It doesn't make sense for their job responsibilities. So I want to take a closer look. I want to understand what led them there. Why are they going to this repo? Why did they download it and run it? And then this outbound connection started. So let's keep chasing this thread. The next place I'm going to check is the Chrome browser history. Just for reference, it's in library, it's in the user folders, library, application support, Google. You can also have multiple profiles. Typically, if you just have one, it's going to be default. But if a user has multiple profiles, it could be default profile 1, profile like X, for example. So let's look. All right, now we have data. If we look at the browser history, you'll see timestamps, URLs. The most recent logs are at the top, older logs are at the bottom. So again, our question is, how did this user end up at this GitHub repo? So if we start there, if we start with the log of them navigating to that repo, we kind of want to look at all the activity before. How did you end up there? So we see just before that they're in LinkedIn. We see that they're talking to someone named Edwin. So just from looking at these logs, we can kind of make a couple assumptions. It looks like they were conversing with someone on LinkedIn, and then they were given a message. That message then was to this repo on GitHub. All right, that's helpful context. But let's look at the browser. Let's look at the full browser history to understand kind of what is the pattern of behavior for this individual. So I've included a few extra logs at the bottom just to demonstrate that pattern of behavior. So if we look at earlier activity, we see they regularly visit LinkedIn jobs. We see they're regularly on their personal email. So we can kind of make some assumptions. This person is actively looking for a new job, and they are actively interviewing, applying to things, reaching out to people. Again, so we have a little bit of assumptions now that it appears this person is looking for a new opportunity. They were contacted on LinkedIn, directed to this GitHub repo. So let's verify. Let's understand what this repo is. Let's browse to it. Let's understand kind of what's hosted there and any additional context to build the story out. Oh, I hope you can see this. Maybe green on black wasn't a good choice, but okay, so I'll just describe it. So it pretty much, when we go to this repo, there's a README file. And the README file is saying, this is a React Node.js skills test. So pretty much what that means is this is a coding assessment. Like this is a job interview step in a process. So the estimated time is 60 minutes. There's a bug fix. There's an API implementation. So again, building the story. The user's looking for a job. They were contacted on LinkedIn. They were given a skills assessment, assuming it's part of a job interview process. Again, thinking it was just normal, benign, job-related testing. But then when they ran it, it's actually malicious with an outbound connection to pull more stages down to the host. All right, so let's put it all together. Let's piece together what we know so far, and let's understand what's happening here. So far, we've looked at browser activity. We've looked at the GitHub repo, and we also have the indicators from the alert. We know the C2 IPs. We know the malware is JavaScript, the dropper, because it's coming from that repo. We also know that the second stage is Python, heavily obfuscated Python. And because we're in a corporate environment, all those assumptions that I made about LinkedIn and interviewing, I can just interview the employee and ask them these questions directly. So let's put it all together. We see personal email activity. We see LinkedIn activity. We see them looking for a new job. I can interview the employee and see that, yes, they were reached out to by someone who said they were a recruiter for a crypto company on LinkedIn. That GitHub repo further confirms it. This is a skills assessment. This is a coding interview, part of what could be a job opportunity. Then we have the IOCs. First stage is JavaScript. Second stage is obfuscated Python. We have known C2 infrastructure. We can piece all of that together and do some research from those in the community and piece together that this is a contagious interview. So this is kind of a known threat campaign done by North Korean threat actors to lure folks in the tech community to kind of just trust people that are actually fake recruiters at fake companies, downloading skills assessments, and then getting malware onto their host. Again, the main goal is money. The North Korea threat actors largely aim to collect, like they'll scrape crypto wallets and kind of any other form of income they can collect off these infected hosts. I'm a very visual person, so let's also put it together visually. So all this data we've collected, we can tell this story now. A user navigated to a GitHub repo in Chrome, downloaded it in their downloads folder. That's the default directory. Ran the repo. That repo then created an outbound network connection on port 1224, which resolves to a domain that's hosting an obfuscated Python file. And because, again, like largely because of the C2s, largely because of the threat reports. We can attribute this. We can say the first stage, the JavaScript, that's what's called beaver tail malware. The second stage is what's called invisible ferret. And if you're, I mean, Chris already showed you this, but Patrick has examples of these samples on his repo if you really want to dive deeper. So it's pretty satisfying, and I hope you feel this way too, when you're given nothing and you can piece together a full story of what happened, how they got there, and understanding the context behind the, like, again, I hope the point of the alert was they can be incredibly vague, but if we put in the time and effort, it can be incredibly interesting. So again, this should feel satisfying. And normally at the end of an incident, it does feel incredibly satisfying to know what happened and to piece together a story. But before we just like go out for drinks, it's important to also take into consideration lessons learned. So it's important to like reflect on the work you did and say, all right, this part was great. Let's keep doing it. Or maybe there's parts where it took too long to get data, or no one knew how to like look at Chrome browser history, like finding gaps in the process and then using that feedback to improve, to continuously improve, whether it's training, whether it's documentation, whether it's process improvement, or maybe it's a detection gap. Maybe as we piece together the story, we're like, we should have had a detection here, here, and here, and we didn't. Or maybe it's a security control gap. So thankfully in this example, we saw, you know, like our security controls worked. We weren't really worried about further stages, but if it hadn't worked, we need to document that and get that fixed. So lessons learned are important. They don't always happen, and it is really a sign of a strong, mature incident response program if they do a lessons learned. So if you're somewhere that doesn't do this, add this. It's important. So I hope you enjoyed this topic. I hope I've piqued your interest, and I hope you're interested in incident response now. Learning doesn't end, and there's always further learning. So I wanted to kind of share some resources for you to do more. A lot of these professionals have already been shown in Patrick's video at the Objective-C conference, but I wanted to give you some options. So if you're new to incident response and you're interested in learning more, Chris Sanders' investigation theory is really wonderful. It's good with like the analytical mindset of question, answer, question, answer. Sarah Edwards does a lovely course at SANS. If you can get the funding to do it, do it. But she also has a lovely blog. Jaren has a great book called OS Incident Response. It's got a new book coming called Threat Hunting, and Patrick's written the foreword, so that means it's probably a very good book. So you should check out all of these resources if they interest you. And yeah, with that, any questions?